Good afternoon. My name is John Funny. I'm the president and CEO of Grice Consulting Group. Grice Consulting Group is a consultancy firm based in Atlanta, Georgia. We are a member firm of the International Roadway Federation. This session is being presented today by the International Roadway Federation. So, a great organization to be a part of. A bit about me. I have 33 years experience in the industry. My consultancy provides city and urban planning, traffic engineering, intelligent transportation systems, and program management. I started when I was 5, yes, 33 years of experience. In addition to that, I was just elected as a policymaker just outside of Atlanta, Georgia. So now I am a government official. I'm a city council person with some knowledge in the area that is ultimately a moving force for mobility within our urban areas. Today, I'm so fortunate and pleased to introduce, we have Dr. Yanis. He's a professor at the National Technical University of Athens. He chairs the ITF Roundtable on Artificial Intelligence and Proactive Road Infrastructure Safety Management. George has a thorough and broad understanding of the transportation sector through his active involvement for more than 30 years as an engineer in the academia world, as an advisor, a decision maker in all areas relating to transportation planning and engineering at national and international level. He has contributed extensively to a large number of research and engineering projects and studies, and in several scientific committees of the European Commission. Dr. Yanis. Our next presenter today will be Dr. Craig Milligan. Craig is the CEO with Intertraffic. He leads a 30-person team in Intertraffic, which is active in 64 cities and focused on helping governments to use artificial intelligence and video analytics within the road safety audit and improvement planning activities. Welcome. And then our final presenter for today will be Orez Lampe. He's the Chief Commercial Officer for Census Gatso. Lampe holds a Master's of Science degree from the University of Twente and has worked with several technology firms in commercial positions. He has joined Census Gatso in 2017 and has since then worked on multiple, or should I say worked with multiple, ministries and public forces around the globe to see how Census Gatso's technologies can support the traffic safety policies as requested in different markets. So as we think about artificial intelligence, this is something that has been floating in the air as we look at a safer mobile environment. How do you utilize the information, the data that's available to us that we may not have grabbed previously from out of the air? So now we have some great research that have been put in place. We have some great practical projects that you'll hear about today that have been implemented. We're so glad to be here today and speaking on this very important topic. At this time, I will call up our first presenter, Dr. Yanis. Before I do that, I have one other item. Each of you will be required to complete a survey before leaving the room. The survey instructs us on how well we did and are we doing a good job, because we're here to provide you with information and technology recommendation and information from the engineering and the research and academia. We want to know how we did. So that scan card there, you would be able to scan it, and there's a chart that's going to be going around. You can complete it there also. Please complete the survey so that we can continue to do the great work of providing you with the information that's needed to support you in your industry and your profession.
Okay,
All right.
so good afternoon, everybody. Of course, everybody's talking about big data. Everybody's talking about automation, automated traffic, automated vehicles. But between the two, we started discussing a lot about AI. AI, artificial intelligence, machine learning, all these techniques exploit big data work for automation one way or the other. Automation of the vehicles, automation for the infrastructure, automation also for driver behavior. Today we're going to make a short presentation of a very nice report of OECD, International Transport Forum, on artificial intelligence and road safety. It is a work that I was honored to chair the respective round table of last year, and then we drafted the report, which is available already since last December. So we're going to see the main findings of this work. Perhaps we can see at the next page the key directions, if we can. In fact, the objective of this work was mainly to demonstrate artificial intelligence mostly on infrastructure, but both ways. Artificial intelligence for from sensors to collect data and put them all together, and then AI at the very end, where we analyze and we provide useful services, products, feedback to everybody, decision makers, users. In fact, road safety, it is stagnating worldwide. Is improving in Europe and in a few countries in the world, but we have to work for Vision Zero. Vision Zero and safe system approach are two issues where we say that we cannot continue accepting fatalities and accepting the mistake of the user. There is responsibility of the authorities, and we have to work with the systems. The operators, the planners, everybody who contributes to save lives. At the next slide, we might see that so far, with the lack of big data and artificial intelligence, we were focusing much more on reactive approaches, where we were looking for high-risk sites. We were looking what happened, analyzing the accidents. We had so much underreporting of crashes. And of course, an incredible lack of data for low and middle income countries. So this is the changing, and it is changing because of big data and because of artificial intelligence. Now we have much more data. Of course, different levels and different aggregation of levels of data. We are working much more on surrogate safety measures, harsh braking, speeding, time to collision, in our analysis. We are working on much more at network level than on real only one crash. So AI, it is a major tool in this quest. At the next slide, we might see that currently there are quite a few applications in terms of road safety operational worldwide. We have a real-time crash risk estimates. Research carried out for the last decade with much more data recently. We have this new era of static or dynamic maps on risk in terms of statistical data, but also in terms of behavior monitoring. We have big crash databases with rare event cases, and we can highlight whenever we have really rare cases, we can identify it through AI. And of course, with infrastructure assessment, with the IRAP methodology, the AI RAP methodology, which has the ambition to go also in the cities, in road safety in the cities. So AI is getting more and more everywhere. At the next slide, we can see AI in telematics. We have more and more data, perhaps insurance mainly, but also in fleet management, where we collect data about harsh braking, harsh acceleration, speeding, and all this data can be transformed. Risk maps, feedback to the user, It can be key information for planners, and key information for operators, including police. So telematics, it is the future, spending to overpass the acceptability and GDPR. At the next slide, we can see, of course, a tremendous work on AI through the automated era, automated vehicles, automated traffic, onboard information. It is tremendous in terms of data collection, and there is AI to transform this on-vehicle information and data into something useful. But most importantly, there is much more need for analysis to make it something taking control of the vehicle and really supporting the user. At the next slide, of course, we know that we have a lot of testing of automation, even in Europe lately, at a quite large scale. We are developing a lot of algorithms, a lot of machine learning and data-driven tools. So this is something that in the coming years is going to bring much more automation in every aspect of driving. At the next slide, we can see that the real question, how we can use AI for policy making in terms of data collection via sensor systems, hotspot identification for operators, for police enforcement. First of all, of course, we should not lose our track in identifying what we need, what are our targets, but also work together, data operators and policymakers, and of course the users in terms of acceptability. And this is the key issue that we're talking a lot about data, but when we come to our own data, we miss the representative samples of the population. In terms of key issues about data and big data and artificial intelligence, the OECD is calling for key issues to work on, inclusive growth and sustainable development and well-being, to use AI also in this perspective. Working on human-centered values and fairness, transparency, explainability, it is a key issue to improve acceptability and create trust. Robustness, security, and safety, fully technical aspects, which are the key component to reliability of AI applications. And of course, accountability, follow up and monitor performance and making it public. Of course, there are a couple of open and key issues that we have to face if we want to make AI widespread. The silo effect, lack of connections between organizations and between teams and the whole society. Technical costs, especially in the beginning and in the transition phase. And of course, privacy protection, which very often it is hiding the competition issues. In fact, AI is going to have impact, direct, systemic, wider, and there are quite a few applications currently all over the world, and Europe is getting stronger and stronger lately, both in terms of research, but also in terms of applications. In synopsis, artificial intelligence facilitates proactive traffic safety management through data collection and hotspot identification in terms of infrastructure. We push the limits of pattern recognition beyond the human capabilities, and we might discover the unknown patterns hidden behind the traditional methodologies. However, we have to make AI algorithms much more explainable, much better understood, because we have to face the black box issue. Main limitations now are data due to isolation and silos effects and lack of individuals with suitable modeling expertise. So we need experts both for data collection through sensors, but also through the analysis. We have much more data than analysis power. And of course, there is a lot of traditional infrastructure not providing data. So we're still having much less data representability and reliability. The two areas where we have to go with AI, we should not wait for real-time big data being available everywhere before developing risk maps. We have to go together, of course. Data and AI, one brings the other. We have to design user-friendly risk mapping tools justifying and support road safety investments, which is something quite concrete at population level. You have seen the revolution brought by Google Maps and all the related OpenStreetMaps and these applications, which are talking to the people's real needs. We have to develop competitive markets. We have to mandate sharing of aggregate vehicle data from the car makers, and we have to align new tools with precise policy objectives and avoid distractions with side goals. Sometimes we want to improve something and we bring the opposite result. We have to develop new skills. We need expertise. We have to support research. We have to clarify regulatory frameworks and not lagging behind all the time the technological developments, and learn from other fields of AI what we can bring, both in terms of competition, in marketing, in data management, and in cost. With this, we conclude this nice work with IRF, mentioning also Alexander Santacreu, who was the really playmaker of the whole initiative of AI of OECD of last year. Thank you very much, and let's discuss further.
Thank you, Dr. Yanis. Don't leave. Great presentation. We had an opportunity to hear how you can get a lot of data, but you have to have the intelligence in knowing what to do with the data to make it applicable to your existing infrastructure, your existing mobility applications. And also, I like the fact that you utilize it in planning for the future. How do you make use of that data that you're getting to be able to put intelligence to it? Without the intelligence, there's a lot of data. Without the intelligence applications, it's meaningless. Any questions for Dr. Yanis? One or two questions, and then we're going to move to our next presenter. Any questions for Dr. Yanis?
Everything was very clear.
Everything was very clear, but I do have one question. The insurance industry has been very interested in getting their hands on the data. Tell us a bit about how the insurance industry is utilizing this data.
Listen, telematics exists already 10 years, but it never take off because people are afraid privacy, but also they don't really value the premiums. Because they prefer to pay a little bit, they prefer not to know their behavior. This is something that we need a cultural change. In terms of road safety, traffic safety, the key issue is not the car, it's not the road. It's not the behavior as such, it is the culture. The culture that I demand a better road, I demand a better car, I demand a better behavior. But we are not there. There are some societies, and the insurance works towards this direction, but is not convincing that much. Percentages are from 3 to 7-8% people choosing telematics. However, it is a growing market. Let's hope.
Let's hope one day we get there, because
that it will come from the people and not from the authorities.
right. Yeah, it's big brothers. Thank you, Dr. Yanis. There's big brothers watching us, and if I'm speeding and I don't want them to know I'm speeding, it could affect the premium. So thank you. Let's give Dr. Yanis a round of applause. Thank you.
I have an application in my phone, and I allow tracking my movements,
Oh.
but I don't show it to my wife.
Thank you, Dr. Yanis. Next up, we have the CEO of Intertraffic, Dr. Mulligan, and he will come and present at this time. Let's see if that's working. Perfect.
Okay, while they get that sorted out, I'll introduce a little bit what I'm going to talk about. I want to first talk a little bit about what is this artificial intelligence we're talking about. What are the core capabilities that it unlocks, kind of at a conceptual level before moving into road safety. And I'm going to talk about 4 things that AI can unlock as core capabilities. I want to relate each of those core capabilities to experiences we have in safe mobility. Can these capabilities make a difference on real road safety issues? Concluding from that, I want to talk about that there is a big promise for artificial intelligence in road safety. That's the first half of my talk. And then in the second half, I'll talk about how we're putting some of those core capabilities to work at Intertraffic for video analytics. So you could guess it from the title that the capabilities I want to talk about are pattern recognition, sensing, perception, and prediction. You know, the human mind is a really unbelievable thing, you know. It can do things that computers have an extremely hard time doing and are only starting to mimic recently. And these are things that humans do very well. We're great at recognizing patterns, sensing, perception, and prediction. And when we can introduce that into a computer, those similar abilities, if we can mimic how the human brain does those things, the advantages that computers have is they can do it at a much larger scale and a much faster speed, especially with what's going on in the processor and microprocessor world, notwithstanding recent chips shortages. So I talked about the outline already. Artificial intelligence, almost all of it uses some form of neural network. And what a neural network does is it takes a series of inputs on the left of that diagram and sends them through a bunch of artificial neurons, simulating neurons in our brain, and sends signals according to the inputs through the layers of neurons. Each signal is weighted up or down as it goes along a path to the next neuron, where it gets another weight to go up or down and gets all the way to an output layer. Okay? The output layer is what the AI model is trying to target in recognition of a pattern or sensing or perception or a prediction. And all AI models have to be trained. And so if you've heard of deep learning, that's the process of feeding a model inputs, but you also give it the output that it should achieve from that input. And so it sends it back and forth in many sample cases, and it adjusts the weights in every neuron in the network until it starts performing well on translating inputs into outputs. I want to talk a little bit about these 4 capabilities. Pattern recognition. Pattern recognition is the ability to see things happen in a repeatable way and kind of know what's going on. And it's our ability to associate. It has a lot to do with associating inputs and outputs. So when you turn to road safety, we have operational traffic flow patterns, behavior patterns, injury patterns, and we also have pattern recognition failures. Okay? There is a pattern in any kind of road corridor where you allow entry from a minor road onto a major road that as the volume on the major road increases, it becomes increasingly difficult to get onto that major road from the minor road if you're going on from a stop control condition. This is a pattern, but if we don't recognize a highway that has increasing volumes over time, that movement is going to get more and more dangerous over time. This is an example. The image is everybody who turned left in a 48-hour period from a stop control onto a highway. And the volumes had gotten so high that this movement was becoming increasingly dangerous. And I wanted to come back and tell you a bit more about that highway a little later in the presentation. So pattern recognition has a lot to do with road safety because there's so many patterns in our transportation network. It's a cyclical behavioral environment. The next thing I want to talk about is sensing. Sensing is how we understand the world around us. What's in front of us, what's behind us, beside us, around us, okay? And that we do through learning by combining sensing and perception together. Okay, sensing is the actual kind of light entering our eyes and other sensing abilities, and then perception is turning that into understanding. But some of the sensing that has to happen in road safety, if you're going to do something like IRAP, he talked about changing from IRAP to AIRAP. Okay, in IRAP, they drive a vehicle and they look at the road to see what kind of features does it have. Does it have an unsafe feature? Does it have a safe feature? So we're sensing what's out there and determining what changes need to be made. I was on a project before I got into AI. We had to measure the characteristics of the roadside of this highway network in northern Canada and determine what areas needed guardrail and didn't, right? And we were using old-fashioned sensing technologies to do that. Today, the slope, the height, the embankment, all that stuff can be gained by LiDAR using artificial intelligence technologies. Perception plays a big role in road safety. Okay, we have to perceive and interpret the world. We have to perceive gaps in traffic. We have to perceive other road user speeds. We have to perceive a traffic control. A sign, what's it telling us? A signal, what's it telling us? And as we move into autonomous driving, this perception has to be done by computers, okay? And there are sometimes perception failures. John, I was telling you we did something on Beaver Ruin Road in your hometown. This picture's from Beaver Ruin Road. Okay. And people were having gap perception failures. It was a long stretch without a pedestrian crossing. And so they would try to perceive if there was a gap in traffic that they could run across the road in. And people fail in that kind of perception, and they get hit by a car, right? A new crosswalk was installed after this study, near to where John lives. And finally, prediction. We have to ask ourselves questions. Where will the next fatality occur? If I do an action out on the road and spend money, will it result in fewer fatalities? What will the road users do? If we can predict, we can improve road safety. If we fail in our predictions, we're going to misallocate resources. So everything from pattern recognition, sensing, perception, and prediction, these are the core capabilities of AI, right? And they're all very relevant to road safety. So I'd say that 1.3 million lives per year, that's the sum cost of all the pattern sensing, perception, and prediction failures that are happening out on the roads right now. And so that's also the promise of how many lives can be saved when we leverage these 4 core capabilities of artificial intelligence. If you can't predict something, you're going to be planning in the dark. And if you can predict, then you can design a scenario that will deliver the road safety that you're trying to target. But it's not enough just to design a scenario. If you can design a scenario through prediction, all that remains is the will to implement it. And we're seeing an increasing political will to achieve a future road safety that we all want to aspire to. So I want to talk a little bit, shifting to how we're implementing AI at Microtraffic. Our goal is to deliver near-miss data to every city from any kind of sensor. We got into this, before I was doing AI, I was running a consulting firm, and we would often do intersection safety studies. And every once in a while, at one of the intersections where we had already done an improvement project, somebody would die, right? We did hundreds of studies all over North America on 4 continents, and someone would die, and then we would try to figure out what happened. We'd go back to the crash data, we'd go back to our field notes, and in almost every case, we found there was no way to predict that fatality from the data we had on hand at the time of the study. And so we came to the conclusion that a lot of the risk out on our road network is latent. And by latent, I mean it's not visible in the crash data. And so the ability to do any pattern recognition or prediction is extremely limited. And this was, in fact, blocking progress in road safety. We were wasting money. We were doing something to respond to the crash data, and then either a different type of fatality would happen or another fatality would happen somewhere else, okay? So we decided to start experimenting with AI, and we put together a tool that used computer vision to measure near misses. And our home province, they were gracious enough to give us a pilot project, and we put cameras up, and we recorded for 3 days, and used AI computer vision, perception, sensing, to measure near misses, which were, the results on that first deployment were shocking to us. There were dozens of people having near-death experiences every single day, even though no one had died yet. That's that scatter plot of people turning left I showed you earlier in the presentation. No one had died yet, but so many people were almost dying every day. $19 million was quickly allocated to reconfigure intersections along the entire corridor, the intersections that we had studied and the other ones. But 8 days before they were able to implement that, and only 8 days after we submitted our data, somebody died from the very risk factor that was showing up in the patterns of near misses that were happening. So this was kind of a sobering moment for us at Microtraffic, or it was at our consulting firm, and that's when we decided, we're going to try and make this technology accessible to every engineer in every city, state, country, and province in the world. Okay? What we put together is a computer vision technology. It measures, detects, and tracks road users. It spatially localizes them and generates a set of trajectories. Those trajectories are then passed from the computer vision models into the road safety models. And what the road safety models do is they take a trajectory file. The upper image is a trajectory file from a little mini roundabout in Friesland province in northern Netherlands. And it's everybody that moved there in a 2-day period, their time-space continuum diagram. And then the risk models move through those trajectories and find the near misses. These risk models have an ability to predict the likelihood of an injury crash occurring in the next 5 years with 94% accuracy. This was published by Dr. Bhagwan Persaud in Transportation Research Record in 2021. So we're putting this predictive data into the hands of road authorities. They can know a fatality is coming before it occurs and then take action to prevent it. How am I doing on time? The timer's messed up. 3 minutes left? Great. So these core capabilities of measuring road users and measuring near misses at Microtraffic, we're using those to support products and solutions in 3 markets. For smart cities, we're starting to offer them diagnostic snapshots, which is from 3 days of recording, they get a diagnostic risk profile of their intersection. And then we're also offering edge analytics. So if there's a camera or a LiDAR or a high-resolution, high-definition radar solution there that's producing object lists, we can stream the near-miss data to a dashboard for proactive insights. There's 95 different cities and communities have used this. They're either in ongoing use or in pilot projects. These include places like Los Angeles, San Francisco, New York, Amsterdam, The Hague, and we're just starting in Australia. Japan's starting to use it. So this desire to predict is really strong, and that's one of the things that artificial intelligence offers, is the ability to predict. In the automotive sector, we're offering training data and warning data to cars. So the training data, the cars have their own neural networks, right? So they have a deep network, they have an input layer and an output layer. Their input layer is an unusual situation, and their output layer is how the car should respond and react to that situation, the autonomous driver. So our contract with Waymo is to supply them unusual situations as their input layer. Then they will define the targeted output layer, how they want the driver to perform, and then they'll just teach it how to recognize those unusual situations. So we're supplying that edge case training data for autonomous vehicle applications. And then interesting, you brought up the insurance situation. So there's telematics in vehicles. Some customers are opting into it. Some insurance companies are having more success in their customers opting in through gamification, where they kind of have the drivers reach different levels of safety to unlock discounts. But one other area besides the basic telematics that insurance companies are doing is they would like to pair, they're now using that just to price on the behavior data. But what they want to do is also overlay a risk map on top of their customer telematics, so that they can price their customers not only to their behavior, but also to the risk in the locations that they drive. So that's the pricing side of what we're doing with insurance. And the other side of what we're doing with insurance is helping them with loss control messaging. So if their customer opts in to get sent messages, very brief, simple warnings when they're getting to an intersection that has a lot of near misses at it, or their navigation system shows that they're going to make a left turn, and that's the turn at that time of day that has a lot of near misses, they can prompt them with a very specific message.
30 seconds.
Okay.
To wrap up.
So that's it. That's what we're doing. If we're looking for people to work with us at Intertraffic, people who have sensors, smart cities who want to try diagnostics, engineering firms, car companies. If you're any of these, we'd love to talk to you about further use of AI in safer mobility. Thank you very much.
Great, Dr. Milligan. Thank you. Thank you for that presentation and learning what the mind is thinking and being able to take that to bring it into the proactive areas of implementing changes so that the behavior would change, because obviously you're learning what the mind is doing, so thank you for that. We sometimes don't know what our minds are doing, but when you learn the pattern and the repeated pattern, you're able to create systems to bring about safety enhancement. So thank you. Any quick questions for Dr. Mulligan before we go to our final presenter? And I will grab a microphone. Here you go. Sure.
Hi, I was wondering why 3 days for analyzing traffic? Because I can imagine, for example, in the weekend there will be very different situations compared to maybe in the middle of the week. So why 3 days?
Repeat the question, because I don't think that mic is working.
She was asking when my mic is off now.
Your mic is off. Try that one. Oh, you're on now. You're hot.
I'm on now. I'm on? No, I'm not on. Okay, the question was, you can hear this mic. The question was why 3 days? Because some things could happen on the weekend and risks vary over time. The ultimate answer is we'd love to have these running continuously 24/7, 365. So that's the Edge Analytics product. Sometimes they can't permanently install a camera, and we chose 3 days as a balance between sample size in near misses and practical feasibility of temporary deployments in terms of battery life, storage capabilities of cameras, and how long they can record for. Yeah, thank you.
Great question. Join me in thanking Dr. Milligan. And at the end, we will have more time for questions, but we'll get our final presenter. Thank you, Dr. Milligan. Our final presenter for this afternoon is Mr. Lampe. Mr. Lampe is with Census Gatso. He's the commercial officer. Did I say that? That's correct. Correct. He's the commercial officer with Census Gatso. Join me in welcoming Mr. Lampe.
Thank you for the introduction, and welcome to everybody. Once again, my name is Joris Lampe, Commercial Director of Census Gatso. And today I'll be talking about a topic which we call distracted driving. And that's basically an application of AI into the world of automated enforcement. But before I do that, I'll talk briefly about our company. As said before, I work with Census Gatso. And basically, Census Gatso is the merger of two companies who have a long history in automated speed enforcement. First of all, the Dutch company called Gatsometer, founded by the Mr. on the left-hand side, Maus Gatsonides, and basically he was the inventor of the first automated speed enforcement camera. And then the other company, which is called Census Traffic, which is fundamental in working together with the Swedish authorities in implementing the Vision Zero program, which has led to a very successful traffic safety program in Sweden, as probably most of you are aware. The 1.3 million figure came across earlier as well. I mean, this is a serious topic that most of the people here in the room, I guess, are addressing. And we are doing that in terms of automated speed enforcement. Everywhere where we can decrease speed, we see a direct impact in decreasing number of fatalities. And on the low end below there, you will see a quote from the Prime Minister in France, where we did a program some years ago, and that had a direct impact on the number of fatalities that we saw in that country, France. Well, the numbers vary over the different markets, over the different continents, but we are very proud that, let's say, in the first 5 prime markets in Europe, we are a vendor of the authorities there. So we think we can contribute directly towards having less fatalities in the market. Now coming to what we call distracted driving, and some of my colleagues in the US refer to this as cellular homicide. We see that everywhere drivers are distracted, there's a direct impact in the number of crashes. And there's here some statistics, I won't read them out, but we see there's about 20 times higher chances, higher probability of people having a crash when being distracted. And it's quite obvious. If you travel at 120 kilometers an hour, you will, if you don't watch the road, you will travel about a football pitch in 3 seconds. And not only because of a mobile phone, but any kind of distraction, you're actually looking at not at the road for a long period of time. So the moment we can diminish that, there's a direct impact on traffic safety. Now for us as a company, we come from the world where we have systems for automated speed enforcement and automated red light enforcement. But now what we're seeing is, of course, then a new area, which is mobile phones. Mobile phones have a direct impact on, as I said before, on the traffic safety, and that's something that we need to address. What we started to do is we put up a few positions where we could see if we could detect whether a person was holding a phone in his hand. And here we see a situation where a colleague of mine is holding a phone in his hand, and the position of the camera is vital towards finding the phone. You could see here that with an elevated pitch of about 6 meters, you could easily see the person holding a phone in his hand. And let's say from the roadside, basically the typical height of which we put traffic enforcement, it was not going to be seen. Here it's the phone to ear, same locations, having the elevated pitch, it was less visible, or not at all visible, but at the roadside you would see it. We choose to go for the previous one, so the phone in the hand, that was the one that's most dangerous towards driving. It's again the same situation where we look at the different locations of the camera, and that's the one that we chose. What we did is then we started to implement an algorithm where we could learn the algorithm basically to see where the driver was located, then to find a hand, and ultimately find a hand that was holding a mobile phone in its hand. So this is an example of the picture that I just showed earlier, with the algorithm being put on top of it. So first, the driver was identified, and then on the next picture you see that the algorithm will pick up whether the hand was holding a mobile phone on that or not. And this is basically the classification of hands. So on the left-hand side, the algorithm can see all the hands that are not holding a mobile phone, and on the right-hand side, that's the classification of the hands holding a mobile phone. Of course, when we started doing this, and it was mentioned before, we are dealing directly with privacy because we're taking pictures of all passing vehicles. And the moment you do that, when there's not even a violation being done, you run a risk of directly impacting or abusing the Privacy Act. So that was a big thing that we had to address. and specifically still in certain markets, this is something that is not allowed. This is about the technical implication. I won't go into detail here, but what we did is we gathered about 70,000 violations in a couple of, 70,000 passing vehicles, so 70,000 images, and we saw that about 2% of the vehicles that were passing were actually holding a phone in their hand. And how did we do that? We did that by looking at all of these images manually, so one by one, knowing whether it was done or not, and then we were comparing it against the algorithm that we had made. Interesting, on behavior topic, we saw that mostly people going back and from work were the ones violating. So people with a kind of behavior on a daily basis doing the same thing, they tend to be distracted, they tend to use their time in a different way. Also, we decided the same thing on specific roads. So some roads were more prone to this behavior than others. Well, this led, of course, to results. And this is a rather complex slide. But the most important thing for us was that we had to get used to the fact that we would not catch all drivers. We come from a field that if we say that somebody's violating, we're very sure that that person indeed has speeded. Here it's a bit different. We had to offer what we call candidate violations. So somebody still would have to look at if the person that was violating indeed was violating, because we could not fully rely on the system that it was always correct. But basically what this slide was saying is that depending how large the file of candidate violations was, we had an accuracy of anything between 87 and 58%. And this is here again the balance that we had to make. Same slide. And this is, let me put it like this. So out of a set of 10,000 passing vehicles, we found 87 candidate violations, out of which 87 were actual violations. So 63 out of this 150 were wrongly offered as a candidate file, and we missed 13. Obviously, it's interesting to have this number as small as possible because they have to be reviewed manually. So we're actually very pleased with that. But what did it offer? These kind of pictures. So obviously, somebody holding a phone in his hand whilst driving. This is on the ring road A10. Another sample image, another sample image. And of course, we also know, can see the license plate. We know the speed at which the car is traveling. So we can quite certainly define that this is a violation. Lastly, some interesting slides, or actually pictures. This is a person traveling at, once again, the ring road A10, not holding a hand on the steering wheel at all. Here's somebody doing something similar, but this is with a 20-ton truck. So that's even more interesting, and I saved the best for last. This is somebody at a moped in a lane at the ring road A10. So, with having said that, I'd like to thank you for your attention. I'd like to give it back to the presenter. Thank you.
Thank you. Thank you. Thank you, Mr. Lampe. Any question for Mr. Lampe on the technology that he presented as it relates to the amount of data? Again, common theme between all of our AI presentation is the data that's coming in a remarkable manner. Any questions for Mr. Lampe? Yes, be right there. There you go.
Thank you. I was just wondering if your project also has resulted in actual violations with the police, or is it just a test for now, or is the legislation and the law around actually doing this already at a sufficient level?
Yeah, that's a good question, of course. We did a pilot project, but I know that the customer, that in this case the Dutch prosecution office, is working on the total chain to actually enforce it till the very end and to send violations on that. But of course, there's more to it than just the technology, right? It's the legislation, it's the administration. So before sending out a violation or citation, you have to be very sure that that can be upheld in court. And I know that different authorities are working towards that.
Good question. I will actually open it up to all of the panelists, Dr. Gilligan, as well as, I'm changing your name, Dr. Mulligan, as well as Dr. Hannes. Any questions for our three esteemed panelists this afternoon? Any questions? He actually asked the question I was going to ask about legislation. Or if you want to ask each other questions, you can do that also.
There are two types of handheld distraction, responding, but also texting.
Texting, yes.
Can you distinguish between the two?
At this stage, I wouldn't say we can't. I mean, if you look at my last slides, some people even argue if you can distinguish if it's a mobile phone or not. I mean, if somebody's saying, I'm holding a calculator in my hand of a box of chocolate, I mean, the photo needs to be very clearly showing that's a mobile phone that's being held. And then how it's being used, that's the second thing, of course.
The analysis is on photo or on video?
Can be both.
Yeah. If it is video, then you can gradually identify more.
Yes, that
in
would
the
be,
future.
yes, that would be nice. But of course, the vehicle is traveling at a certain speed.
Yeah.
That would mean that you would have to follow it for a
The
certain
small
length of time.
window, the time frame, enough to...
No, but again, that's also legislation. What's the use? I think in certain countries, the legislation is now being adapted towards it doesn't really matter what you do with the phone as long as you hold it in your hand, it's not allowed. So in that sense, also legislation is supporting the enforcement of these kind of types of behavior.
Good question. Good. Any other questions? Anyone in the audience? I'm taking an audience poll here. Any other questions? Oh, thank you, Dr. Giannis.
All right. If
Please
the
address
road,
which panelist you're asking also.
it's a question to you.
Yes, okay.
If road safety really is in focus of your solution, are you planning to also collaborate with the car manufacturers that are currently implementing driver monitoring systems to also identify whether a driver is distracted? Would that be a use case that you would consider?
Yeah.
Or are you really looking only at the side of the infrastructure where you more or less be able to give the data to municipals, cities, whatever?
No, that's certainly a good question. But I think the question here is who is the trusted party? So indeed, vehicles can already monitor quite a lot of things about what they're doing. But if the car data would be telling you or the authorities that the car is not speeding, would you trust that data? I mean, people can maybe also put in different kind of software that the car is sending something out differently than what it's actually doing. So I think that the truth of the cause is who can be trusted here and what data is right or false.
I just say it out loud. So the driver monitoring systems inside a vehicle is really tracking what the driver is doing, whether he's holding a smartphone in his hand, whether the driver is looking at a child in the back seat or so. So I think you're describing something else.
Okay, now, but maybe the same is applicable. It's about enforcement. So if the car says that the driver is not paying attention, would that be sufficiently strong evidence to hold up a violation?
Yeah, in most jurisdictions in the United States, for example, in order for a violation to be upheld based upon video or any type of application in the car, it has to be validated by an officer. And that officer has to sit in front of a video camera and watch the violation in order to issue a citation.
That's correct.
So it's different across the world, across the country, but that's how it's in the US. And that has helped in some cities. Some cities have put in technology and applications to allow the technology to record the violation. And then the officer gets shipped the video packet. He downloads it, watch it. It records the license plate numbers. It's able to visually see the face. And then he sits there and he writes out a citation or types it out or whatever. But it has to be validated.
That's correct.
Okay, I'm going to, you can come up after the presentation. We do have limited time here in the studio. So I want to get you all to thank our panelists for doing such a wonderful job with their presentation. And thank you for being a wonderful audience And thank you for your wonderful questions. Have a great evening. And again, this session has been produced by the International Roadway Federation. Again, I'm John Funny. I'm CEO of Grice Consulting Group, a member of the International Roadway Federation. Thank you and enjoy your Intertraffic experience.
Thank you.